On page 56. Everybody look in the circle? Pinpoint 45 degrees. Everybody got 45 degrees? The first value is the cosine value. The second value is the sine value. So at 45 degrees, what is the cosine of 45 degrees? Square root of 2 over 2, right? What is the sine value at 45 degrees? Same thing. Okay, square root of 2 over 2. So, if cosine is the square root of 2 over 2, and we know that the secant is the reciprocal of the cosine function, right? So then secant at 45 degrees will be equals to what? Rotating that thing, right? So the 2 comes up, square root of 2 goes in the bottom, right? That's what we did yesterday, just turning that thing. But can we leave it that way? No. So then what we do here is to multiply by the BC1 right on top, because that times that. What's the square root of 2 times the square root of 2? Square root of 4. Do we know the square root of 4? All right. Right? And the 2's cancel out. So this is just the root of 2. So both of these are not right. This should just be the root of 2. And I'm going to do the same thing for cosecant, because the sine is the same thing, right? And then that would be the answer. But it's amazing how the person with a 1 also had a secant in 1. And people still have a problem reading that circle. You have to be able to read that circle at this point to survive this group. Because we've been dealing with that circle from page 26. Now we're on page 56. We still have the circle. The first value is your cosine value. The second value is the sine value at the angle. We're good? So here's the point I was trying to make. If I have a triangle, a right angle triangle, right? That's SOH, right? For so, right? What's cosine? AH, right? And then tangent? Okay. We know those things, right? Now, what is the reciprocal of the sine? Which one of those 3 things we learned yesterday is the reciprocal of the sine?
Oh, no.
Right? So if sine is opposite of a hypotenuse, what's cosecant? Right? Hypotenuse over opposite. If cosine is adjacent over hypotenuse, then the secant is what? Hypotenuse over adjacent. Right. Hold on. Now let's do this thing here and see if we're making a song here. So if the tangent is the opposite of adjacent, then what is the cotangent? Ow! Ow! Questions yet? So, if I am given a right angle triangle, then if I know the 3 sides, if I know the opposite of the angle, the adjacent of the angle, and the hypotenuse of the triangle, I can find sine. Opposite of a hypotenuse, I can find cosine. adjacent of the hypotenuse. I can find tangent opposite of adjacent. But I can go back and find the other three we talked about yesterday, right? I can go back and look at the cosecant as the hypotenuse over the opposite. Right? And I can find the secant as the hypotenuse over the adjacent. And I can find the cotangent as the adjacent over the opposite. Just rotating stuff now. We good? Good, because we got to do some work today. So we get to put away the engaged New York, not for a whole long time, but today we get to engage BC. So we get to work on this thing. John?
Yes.
You want to project the other side? Okay. So here's what I'm doing. So on the front of that thing, are we ready? Are we ready? There is a remember the time, hey guys, there is a Michael Jackson moment, there's a remember the time moment where it talks about angle, angle, angle. So you see that AAA from when you did geometry. Don't gossip, I'm just talking about when you did geometry. Okay? So we had, remember you had an angle, 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 side, 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 angle, side, angle, right? All those things, right? Don't panic, we're not going into geometry right now because they're like, oh crap, we're about to learn that, I forgot. No, it's just trying to talk to you about similar triangles. So pretty much, the things we just did on the board, where the sine being opposite over hypotenuse, is the exact same thing you did trying to get you to do on this front page. So you're setting up cosecant and secant in the same form that we did over there. Where I want you to start working is when you flip the page. I'm going to do one of these, but we're going to do one of these together. And then you got to do the other one. So we're looking at problem 1, a triangle that has FGA. Everybody seen that triangle? All right. Okay. So, are we paying attention? With respect to angle A, here is angle A. With respect to angle A, this 9 is the opposite side. So I want you to mark your work that I'm doing.
Got it?
9 is the opposite side, and the 12 represent what? Adjacent. And then the 15 represents the hypotenuse. So now we have a right angle triangle with 3 sides given to us. And they're telling us where to look at this thing from. They want us to look at it from A. We're good? Now, sine of A from SOHCAHTOA is opposite over the hypotenuse, right? We just named the opposite to be what? 9 over the hypotenuse, 15. Yeah, but we can reduce that, right? Because we go to BC, right?
3.
Right. So we reduce by 3, we get a what? 3 over 5. Now that's it. That is sine. Questions? If I know sine, I can find cosecant right away, right? Because it's just the flip of the sine, yes? So what should be the cosecant? So the hypotenuse over the opposite, 15 over 9. If you look here, sine was 9 over 15. Cosecant is 15 over 9. Because we're just flipping it. Okay? And so then when we reduce, we should get 5 thirds.
When you do that, do you have to write like the main one first? If you already got the regular sign?
Well, if I already got 5 over 3 for sine, then I don't have to show all my work here. I can just flip it and put a 3/5 here, right? I mean a 5 over 3 here. But I want to show the work so you see where it's coming from. So when you study, you know where it came from. But on the test, no, I don't expect that. If you already find sine and cosine and tangent, then I don't expect you to show me all the other pieces. We're good? So then we'll go back to cosine. Cosine is adjacent over hypotenuse. What is the adjacent side we just marked? See that? 12. So 12 over the hypotenuse, which is still 15. Can I reduce that to what? 4 out of 5. Oh, crap. What?
I said, why not a 2?
Why not a what?
A 2.
A 2 over 5?
2 doesn't go into 15.
2 does not divide 15.
No, I'm talking about 12.
Is it 4 into 12?
Yeah, we're dividing by 3s.
Oh.
Yeah, the 4 into the 12, the 3 into 12 is 4. 3 into 15 is 5. Are we good? Yes? Okay. So then if I know cosine, I can go right away to my secant, right? Because the secant is just flipping the cosine. So that means my secant is going to be hypotenuse over adjacent. I'm still using adjacent and hypotenuse. I just, one of them come on top, the other one goes on the bottom, depending on what we're talking about. We're good? So our hypotenuse is still 15. Our adjacent is still 12. And when I reduce that now, I get 5 over 4. Is there anybody with a question? No? All right. Then let's look at a tangent. From SOHCAHTOA, the definition of tangent is opposite over adjacent. The opposite is still 9, and the adjacent is still 12. If I reduce 9 out of 12, what do I get? 3 out of 4. Are we good? So now if I know tangent, I can find cotangent by just flipping it, right? So if the tangent was opposite over adjacent, my cotangent is going to be adjacent over opposite. And we say our adjacent is 12, and our opposite is 9. And so I get 4 out of 3 when I reduce. So here are my values. Is there anybody with a question? So I got a 5 and a 3. They got a relationship. First time the 3 is on top, the 5 is in the bottom. Next time the 5 is on top, the 3 is in the bottom. right? The first should be last, the last should be first. Sometimes you got to be flipping in and out. And then we got a relationship between a 4 and a 5. So first time the 4 is on top, the 5 is in the bottom, and the inverse of that is the 5 is on top and the 4 is in the bottom at the secant level. Everybody see that? So we should not have the exact same answer unless we're dealing with just like a square root of 2 over 2 all along the way, maybe. So then you should be able to do the next 2 columns following the exact same example, okay? So let's look at number 2, because I got to do some problems in number 2 before I release you to do your work for the day. So in number 2, yeah, I know I'm violating my own rule here. That's why I wrote that in all cap. That C word, that bad word. But I wanted to say that because a lot of you are going to still keep using your calculators, and there are some angle measurements that we just can't find in the unit circle so easily. So when you take the calculators that are in this room, chances are they might be set to radian, because my calc students use radians. So in order for you to make sure you have the right answer, you have to change them to degrees. And the way to do that is to click on mode, and then it will be the screen that will show up. The first thing will be float. You're getting past that. You're going down to the third one. If it says radian and it's highlighted, just click over 1 to degree and push enter. If it's already at degree and it's blinking at degree, then keep it at degree. Okay? Now those of you with your cell phones that you use, when you open up the calculators on the cell phones, on the smart cell phones, and you lay them sideways, then it shows you all of the stuff on there, right? Now, however, if it's in degree mode, you will see DEG on your screen on the bottom. If it says RAD, that means it's in radian mode. You need to change that to DEG, to degree. We'll talk about radians in a little bit when we start measuring angles. Instead of in 360 degrees, we start measuring them in 2 pi's, because there are 2 pi's in a circle. Then we'll go back to radian. Then we'll talk about RADs. Okay? So for now, all you need to do for tangent is, it says use the calculator, so just push 10, 24, enter, and they give you an answer. Now if you're using your cell phone, you might want to push some of them will want you to first put a degree, so you put 24, and then tangent. So you got to figure out how your cell phone works. But it should give you an answer. Now, tangent, sine, and cosine, I'm not terribly worried about, because we can find those easier in the calculators. I'm worried more about secant. If you're looking at calculators buttons right now, and if you have one of those cheaper ones like the ones we have, there should not be a secant button on the main screen. Correct? There are only sine and cosine on the main screen, right? Do you have a calculator with a secant button on it? You do?
But it's an app.
It's an app, yeah. I'm not talking about an app. There's an app for everything, right? Goya's crazy. There's an app to fix that. But no, we're not trying to fix that. So now, secant. In order for us to answer the question about secant of 72 degrees, we need to know which of those 3 keys on our cell phones, sine, cosine, and tangent, that secant relates to. So if you forgot, look back at page 55 in your holy book. Page 55 in your holy book has those relationships that we talked about yesterday, right? So which of those 3, sine, cosine, or tangent, which one of them does secant relate to? Cosine. So we said secant is 1 over cosine, right? So if I'm given secant of 72 degrees, then I know that is equals to 1 over the cosine value at 72 degrees. So then all I need to do is to find the cosine value at 72 degrees, which is 0.3, is it? Check that for me, please. Cosine 72, 0.3? Okay.
0.30.
0.30?
Oh. You said, oh, is it, oh. Okay.
Ms. Will, I am. Okay. Now, this answer should be 10 out of 3. But if you don't see how I'm doing it, I'm going to change my denominator to a fraction. 0.3 is 30%. 30% is 30 over 100, or 3 out of 10. This is a fraction, that means 1 divided by 3 out of 10. And remember fractions? We keep the first one, change the sign, flip the second one. What's 1 times 10? And 1 times 3? So your answer is 10/3, or 3.333333333. 333333333. 3. 3, 3. 3, 3, 3. 3, 3, 3, 3, 3.
I think my calculator is broken.
3. 3. Can I stop now? No? Okay. Another 3. Tekai, what did you say?
Where did you get 10 from?
Where did I get 10 from? So you see 0.3. If I want to change that to a fraction, every number can be placed over 1 as a denominator. So then I'm going to just move the decimal point. However many times I move it, is that many 0 I add. I move it 1 time, I get a 3 now, right? So now on top I got a 3, but that just gave me a 10 in the denominator. So that's how I changed that 0.3 to that. Yes, ma'am?
Can you look at this?
Sure, 1 minute. Are we all good though? So then if I have a cosecant for f, I got a cosecant of 40 degrees. But my calculator button does not have a cosecant key. So how do I trick it into finding cosecant? What relates to cosecant? Sine, right? So I find sine at 40 degrees. I'm just going to do 1 over the sine value at 40 degrees. Does that make sense? Are we good? So find a cousin, work on this packet. That's the work you got to do today. Do a lot. Don't just do 1 page. Actually do almost all if you can. I'm going to give you a gift if you do all of them. I'm going to knock you in the head if you don't do all of them. That's a gift also. So black pie out. LOG, black pie.